Welcome to today's webinar, Reinventing Maritime Big Data Organization. My name is Mark Porter, and together with my colleague Annabelle Gonzalez, we work for Geospoc, a technology company who are operating in that field of big data management and organization. Just as a quick agenda run through, I will introduce Geospoc and some of the problems that we see with existing systems of big data organization, what the challenges are in that ecosystem, and how we as a company attempt to address those challenges. Annabelle will then go through a couple of demonstrations of that system of management in action, and then I will come back and discuss Geospoc in the maritime sector and what we hope to get and I hope to see in the future in our future activities. And then, of course, we will open up the floor for any questions. I am going to try and record this webinar, and I will send out the slides afterwards to everyone who's attended. So if you could keep your microphones on mute unless you have a question. And if you have a question that you would like to pose, write it in the chat and we will try and get to it either at the most appropriate point in the presentation or at the end. Thank you. So, without further ado, thank you for your time this afternoon, and thank you particularly to the Singapore Shipping Association for organising and hosting the webinar, and to the MPA at Singapore for facilitating this process. Reinventing big data organisation. So, wherever you are in the world, at an individual or an organisational level, extreme scale data environments are becoming the new normal, and everyone is interacting with data in a more and more extreme manner. Everyone has a mobile phone, but increasingly we also have connected cars, and increasingly in the industrial sphere, devices, assets, and other items of equipment are being connected to the internet to form the so-called Internet of Things ecosystem. And it's estimated that around 83 billion devices will be connected into that ecosystem by 2024. Truly exponential drive in increasing the amount of sensors in the world. And what are those sensors doing? Those sensors are recording data to provide better visibility of everyday operations and everyday lives. The maritime sector is no different to any other in this regard. A vessel is very much a connected device in the ecosystem of the Internet of Things. It has Wi-Fi, it is connected via satellites, and it is very much part of that ecosystem, as are all the other components of the maritime industry. And in fact, it's estimated that around 100 million new data points are created in the maritime sector alone each day, and that's today. So this is fantastic, and this means that there is an opportunity for the industry and for other industries abroad to really get much better precision and measurements and much better visibility of their operations. And as anyone who is familiar with continuous improvement and improvement methods will know, measurement and data is the first step towards operational improvement. But that data and all those data points have to live somewhere. We are generating around 54 exabytes of data by 2022. So you're probably familiar, most of you, with gigabytes, but above a gigabyte is a terabyte, and above a terabyte is a petabyte, and above that is an exabyte. So this is orders of magnitude of data larger than we come across in our everyday human experience. And while this data is a fantastic resource, there are some challenges associated with this hugely extreme explosion of data in the modern world. 90% of data value is currently being lost already today. Many organizations understand the potential of data, and many organizations are now recording data on all facets of their operations. But much of that data effectively sits idle, gathering digital dust, and is not used to create its full value potential. And there are two main reasons for that. The first reason is that volume problem. There's simply so much data that it becomes difficult to wade through it all to find the relevant pieces for analysis and insight. This is exacerbated by the existing infrastructure of data management, which breaks data into silos. Data silos prevent individual data points from being communicated and contextualized in a wider environment. Data is not valued on its own. Data is only valuable when it is turned into information and insight. Data silos prohibit this and raise huge barriers to innovation. And both of these systems, both of these problems, the problems of volume and the problems of siloing, are an infrastructure problem. Simply put, standard databases cannot cope with the volumes of data that are now being produced and must therefore silo it away and make it more difficult, but that makes it more difficult to access. And fundamentally, overcoming these challenges is critical for doing better business. The world is changing, and increasingly it is becoming necessary to combine data across silos and across disciplines and across areas of domain expertise. The same data that drives your optimization processes can improve your sustainability operations and help you better characterize risk. These are not fundamentally different areas requiring fundamentally different databases and fundamentally different data architectures. The same data and similar modeling techniques can be applied if that data is housed in an infrastructure with the flexibility and scalability to deal with those problems. And this is exactly what GeoSpock was founded to do. So Dr. Steve Marsh, our founder, founded the company in 2013 following his research at the University of Cambridge. And we're now 60 employees dedicated to solving the challenges of big data management in the real world. Data scientists, technology and software development. And as well as having offices in Cambridge, we increasingly have seen activity in Asia. We have given lectures at the Singapore Institute of Technology and our data science team. And Steve himself is a fellow of the Singapore Smart Nation program. And what is it exactly that GeoSpock do? Well, we provide an innovative database to address the 3 V's of big data management. And a database is often overlooked, I think, in the world of data. Everyone wants to record more data and everyone wants to analyze that data more effectively. But the database is the bit in the middle that organizes and houses that data and ensures that it is accessible across an organization. And the GeoSpock database does that for big data, uniquely for spatial big data. So we address the problems of scaling for that volume that we talked about earlier. And we also address the problems of adapting to the huge new variety of data sources, data connectors, and data uses that are proliferating in the world today. But we want to address those 2 V's and the 3rd V of velocity. It's no good bringing in 100 million data points a day if it takes us a week to analyze and get insights out of that. We need to be able to deliver insights to that from that data at velocity. And in the real world, data is particularly complex. Not only do we have a proliferation of devices, more vessels, more sensors, more connections, but they move around both in space and in time. These are not static objects. They interact with each other, they interact with different systems, and they move around in both geographic sense and in a sense of time. This adds 3-dimensional complexity to the data, which makes spatial data particularly difficult to manage. So how do we do that? Well, at GeoSpock, the core of our technology is based around an efficient method of indexing within the database. Without indexing, data is unorganized and jumbled up. It's a little bit like walking into a giant library where all the books are just randomly stored on all the shelves. Even if you know that library contains the book that you want, you may have to walk down every single shelf, checking every single book to find the one that you want. That is incredibly time consuming. And for data, it's no different. It's both time consuming and very costly for computers to search through that database. However, with indexing, we are able to effectively signpost and flag where that information lies within the database, such that we can zoom in straight to the areas of interest That reduces the amount of time that it takes to get to an insight and dramatically reduces the cost required to compute, get that insight out of the database. And so indexing is the key to organizing the data at volume and providing that data at velocity. Second to that, our database sits on cloud technology. So we are an Amazon-based database. And what the cloud gives us is an ability to scale our database to store that volume of data almost limitlessly. It also gives us much more flexibility in its access. Wherever there is an internet connection, you can access the database. And we are able to flexibly interface with a multitude of different tools to enable that accessibility across an organization. If your data science team wants to use the data in that database to generate models, they can do that in the same way and using slightly different tools as your business intelligence analysts do. Equally, we can visualize the data on maps and in charts to enable it to be presented in a meaningful manner. So the cloud provides us with scale, and it provides us with flexibility, and it provides us with accessibility. And what does that result in? It results in a database which can scale in terms of volume almost limitlessly. We have ingested over 1 trillion rows of data into the GeoSpot database. So ingest is just incorporating data into the database. And we do that in an order of magnitude faster than you would if you did not have the smart, intelligent indexing process. What that practically means is the cost base of the data and the data management is incredibly low. And that's great for organizations which want to do more with data. Instead of worrying about the costs of data or worrying about how they might have to use statistical techniques to break down their data before even doing any analysis, they can simply focus on what is the value potential within that data set. And what of the third V? So we talked about volume and we talked about velocity, but what about variety? And variety is a chief source of complexity within existing data management infrastructure. So here is a simple diagram showing a few different data sources along the bottom and data uses, application uses along the top. And for an existing management system of data, this is largely the case that we have today. Different data sources come in and they are fed into different data applications individually. And that's great. And it works, except when you want to add new sources or you want to do more things with your data and you want to ensure that your data remains up to date and you want to keep the costs of data redundancy and multiple copies of data down. Because quite quickly what happens in this system is that we build up a complicated web of data flows and connections, which is very difficult to manage. And this is why silos form, because it is easier for us to simply separate the environmental management system from the operation system. And it's more practical to be able to deal with them in isolation. But that isolation reduces their value. It also increases the overheads of data management massively. And in your individual lives, I'm sure you come across this. How many times have you worked on a document or a spreadsheet, which you've then sent to a colleague who's made some adjustments and sent to someone else for approval? All of a sudden, there are 3 versions of the same document. All of those documents are not quite complete, and all of them show slightly different information. And while that can be a source of minor irritation at an individual level, at an organizational level where we have thousands of different data sources and different types, this results in hundreds of thousands of dollars of cost and thousands of hours of manpower in re-engineering data architectures to deal with that redundancy and deal with those issues of keeping data up to date. We want to get rid of silos. We want to make data access simple, and we want to make sure that whatever bit of the organization you're in, you can access data knowing in confidence that it is the correct part of the data. It is the single source of truth. And so Geospot's way of addressing that is to provide a holistic system of data management, breaking down the silos and promoting that single source of truth. All the data sources can be read into a single Geospot database, from which you can power a multitude of applications in the knowledge that all of those applications can be built and scaled flexibly, and in the knowledge that should they need to communicate and should they need to ensure that their data is the same, they are all using the same original data source. This massively simplifies the data management process and reduces the cost of that data management infrastructure. And what does that practically mean? Well, it practically means that organizations can focus on doing more with their data, whatever their area of expertise. So I'm just going to switch focus now, briefly, and talk about an example of big data in maritime to help you understand a little bit about what we're talking about here. So this is some work that Geospot did with the Baltic Exchange and UMass, a maritime consultancy, on quantifying global vessel emissions. So on the left, you can see a map of the global distribution of CO2 since 2015 for the dry bulk and container fleets. And that equates to around 1.5 billion tons of maritime CO2. And on the right, you can see the data layers that went into that. So we've used AIS data, married that with ship specification data, and reported emissions data, and put that all into a single database to enable this visualization and analysis. And I'd like to look at this in three different ways. The first way to look at it is in what it's showing us, the power of big data. And the power of this tool is that where once analyzing global vessel emissions on a scale such as this was the domain of multiple year academic studies, nowadays we can do this dynamically in the blink of an eye. And not only can we look at it on a global scale, but we can zoom in on local regions. So here is a local time scale. So here is 2019's emissions of sulfur oxide within 12 nautical miles of Singapore ports. So we also managed to flexibly change the type of emission that we're looking at. And this is really important because it means that as well as getting a global macro picture from data, we're able to understand our own individual contexts within it. And certainly for sulfur and Singapore, the local urban air quality health is closely related to air emissions, a significant factor of which comes from vessels. So as well as looking at it from a terms of the fantastic capabilities of that velocity that we are able to do this analysis at, we can also look at it in terms of what other data could we be adding to this data set, and what other data could we add to this database. This database just contains the bottom three of these blocks of data, if you like. But we could add weather and climate and air quality metrics to this data, and that would give us an even greater contextual understanding of how that emissions information is influencing other factors of life, be it air quality in Singapore, or how is weather causing the dispersion or clustering of those emissions. Equally, we could look at it from a more financial perspective or a more commercial perspective. Do different cargoes and do different trade routes have fundamentally different emissions profiles? So this is the type of additional information that can be added simply and flexibly within a holistic database system of management. In existing systems, it would require completely new applications to be developed to incorporate these new data sources. But in the Geospot database and in holistic data management systems, these new data sources can be combined easily and effortlessly into the same analysis sphere. The third way of looking at this data is to look at it across areas. Yes, we're talking about emissions here, but look at the building blocks that have gone into this emissions model. Many of these building blocks are the same building blocks that could be used to characterize risk, to improve operational efficiency. Data is use case agnostic, And siloing it limits the value, the potential of that data, and limits our ability to understand the broader context of data within our operations. AIS data is most certainly not emission specific. Neither is ship specifications, and neither is weather or cargo information. By opening up data in a more holistic sense, we are able to more easily understand how different aspects of data affect different areas of our operations. And so I'm just going to hand over to Annabelle now, who's going to talk you through a few examples of that big data in action. I think we might touch back on that emissions area again, but we're also going to look at some environmental and traffic data in Singapore. So I think if I stop sharing, Annabelle, are you there?
Yeah, I'm here. All good from this side.
Great.
Right. So let me introduce myself first. My name is Anil. I was a physicist, and then I moved into data science. And here in Geospoke, I mostly deal with fusioning large-scale datasets. In this case, I will show you two examples. One that has been done for GovTech here in Singapore, and another one that was done for the Baltic Exchange. Because Mark already showed you the example of the Baltic Exchange, I will carry on with this and hopefully give you a good impression of what we did in the past. So the first part to note is that this was a collaboration between different entities. Was between the Baltic Exchange, UMass, and UCL that they generated the emissions model, and us that we were the database that brought everything together. As well, we got the AIS data from Exact Earth, which was the fuel for this development, in the sense that without that, and the emissions model will not be able to work, and we will not be able to put the results in our database and essentially build the system. So there was a contribution between different parties, and the result is summarized here. There's more than this, but I think that this captures the essence of the project. So this project was focusing in calculating emissions for ships around the globe. So the first thing that we can note is that we can select through years, and we can do the global distribution or an amount of CO2 that was emitted through the past couple of years. At the same time, we can also do sulfides, that is SOX, and I think that is quite important and highlights the flexibility of the platform. That if you have data from different sources, you could put it in our database and power different applications. So something interesting is that we can go from this large scale statistic or graphic that I showed here, that is the whole world, and we can move to local insights. So for example, what happens around Singapore and the pollutions around there. I will show you this in a second. And besides going through the years, as I said before, we can follow up what happens in Singapore. And this is very interesting because for institutions that would like to carry out analysis of different signals, or in this case pollution, but it could be others as well, this tool allows them to have a global view and zoom in into the particular areas of interest. Something that could be interest to ship operators is having access to similar insights, but as well as the video will show in a little bit, you could start having aggregated results, and these aggregated results could be, for example, by shipping routes. In this particular example is the emissions of the route Santos, Brazil to Singapore. And obviously, although this is an emissions example, a pollution in particular, this could be, this type of analysis could be done for other examples. So once again, we're going from a global insight to something that is fairly localized. And I think that these examples in which we went from global emissions to local emissions around a country, and then inside of trading routes, they highlight what this example was about. Though obviously we can go even deeper, and there's not shown here, we could go to individual ships. So for example, a typical use case, it would be to take the data stored in the database and present it to someone that would like to exercise some sort of compliance in the ships that you might own or that someone else might be interested in using or purchasing or interacting with. So, well, the example is about emissions, and we saw three cases of how emissions could be studied. The database could power other applications that you may require. So that's one of the cases that we have done. And the next one is about the Smart Singapore. So this one was, we developed it this year. And let me show you how it looks. So it's a very different application. It's about mobility here in Singapore. It's about using a very large data set that is inspired by the ERP2 data that would track cars around Singapore. So let me show you what we did. So obviously the Smart Nation initiative in which we were involved, we would like to provide a nationwide data fusion platform. So bringing different data sets, putting them into our database, and then supporting use cases or applications. And as I was mentioning before, one of Mark said it, one of our advantages and what we find useful is that we bring different data silos, we process them, we put them into our platform, and we can power applications that you might use in the future. Right? Some of the data sets that we have used, they come from a wide range of institutions, for example, LTA, MPA, HDB, and others. So I think that the wide range of data sets might be something that you may face in the maritime sector. So one of the highlights of this project with GovTech was that we used a really large data set that could track vehicles around Singapore. We had GPS information that is similar to the AIS data, not the same, but fairly similar. And we could track vehicles around Singapore. A good description is what you see on the left, that we have thousands of cars moving around Singapore, over which we visualize them, and then we did a bit of analysis. So we're going to go in the coming minutes to there. Oh, sorry. There was a mistake there. So something that you will do, just like in the previous case, is visualizing the data. So for example, this is a snapshot of the traffic in Singapore. Something very hot at the moment is a digital twin of Singapore. So this is a small example of what you could achieve with our platform. Something that we use are tools like this one, such as W, to get the data. But it could be something else. It could be a reporting tool that just gets you a PDF with the information that you would like to know. It's fairly quick. It's an industry standard, so something that we can manage, or if you have teams dedicated to this, they could easily connect to the database. For example, a use case that the government or GovTech was interested is to analyze the origin and destination of trips. So in the day, people commute to and from work. In this example, you can see where people are going from and to in the morning at 8 to 9 a.m. So, for example, we can see that people goes from the north and the west. Most of the trips they start there, and there are a few nearby Happy Valley as well. And the destination is mostly around the city center, the CBD area, which makes sense as is the heart of Singapore. This application is just a couple of lines, and it's very easy to visualize what's going on. So this is something that we have delivered for GovTech. That's very interesting. Additionally, we did another use case that is basically calculating distance travel in a certain area. I think that the applications of these two use cases are straightforward in the case of Maritime. So you could exactly calculate the distance that a ship has traveled, and perhaps start applying charges to that trip, depending on factors such as weight, or emissions, for example. On the other hand, it could serve for people that are trying to lower their emissions to get financial benefits, or as well insurance benefits if there is such a thing in the maritime case. So let me show you how that will look. Although not as exciting as the previous graph, we can calculate a distance for vehicles that enter the downtown area, and there's a certain charge for them. And obviously that is related to the amount of distance traveled in the downtown area. In the case of Maritime, it could be on a distance travel in a port, or between two ports, or around or different routes, as we saw in the emissions case. We could apply the similar analysis to calculate the distance travel. As well, for example, if you were interested in finding out ships around a point of interest, this is something that we can easily do. Although this is done for data scientists, we can translate it into a web app fairly simply. So, for example, we can identify all the vehicles or ships in the maritime case that were around an incident. And if we would like to dig in even further, we could focus into one vehicle and see where it has been in the past month. So I think that this gives you a really good idea of what we can do. We can go from really large global insights to analyzing particular events. So, for example, this could be applied to anomaly detection. Find out where ships are, but they should not be. Or if an accident happens, we would like to start finding who was involved, or how it could be avoided in the future. So, with that, I think the message that I wanted to convey here is that we have different data sources that produce really large amounts of data, and if they are stored in our database, we could power applications that give you a really large overview, a high-level overview of what's going on with the data, but also give you a very granular insight in case that you require it. So with that message, I will pass it back to Mark. So hopefully you got a good idea of the type of applications and services that we can deliver and that we have done in the past. So I will pass it to you, Mark.
Thanks, Annabelle.
No worries. My pleasure.
So what are the key takeaways so far? So from Annabelle's demo and from the previous examples of the maritime emissions, we can see that many of today's most pressing challenges require the integration of data from a wide variety of disparate sources and across traditional areas of domain expertise. So Annabelle showed how Effectively, GPS data in Singapore can be used for both commercial reasons in understanding how travel moves around and could be priced within Singapore, but also it could be used for investigating specific events, for intelligence or security purposes. And the same thing can be done with maritime data. But to address these challenges really requires a more modern, holistic approach to data management. Fewer silos and more flexible methods of data combination, which enable these multiple applications to occur seamlessly and more efficiently. And if you do that effectively, organizations are able to focus on the cost, not the costs of data, but the benefits that they are able to get out of that data, extract more insight and value, and reduce their overheads and reduce their redundancy. And no longer does data become a huge weight on the organization. It becomes a positive and a benefit, and organizations are fully able to take advantage of that data, no matter the use case. And so just to touch on some of the areas which we believe at Geospoc our database could be useful for in the maritime sector particularly. Top left, we've talked about dynamic modeling and quantification of emissions, which has a range of commercial use cases, everything from activity-based emissions inventories, where the amount of carbon or the amount of emissions is generated due to actual vessel activity or local activity in ports. And additionally, that can be used to get visibility around the whole supply chain of emissions and really understand and characterize the differences in footprints for different aspects of behavior within the maritime supply chain. Equally, similar data and similar data techniques can be used to look at risk assessment in the sector. Already, companies use AIS and similar data sets to identify suspicious activity or dangerous behavior. And we're beginning to see the use of telemetry to individualize insurance premiums down to a per vessel basis. At the more macro level, we can look at modeling black swan events, such as the coronavirus outbreak we are living through now, to better inform and mitigate mitigation and recovery strategies in the future. The same data fundamentally that powers those micro individualized telemetry analysis can be used to feed into the better modeling. Of course, we can also do that in operational sense. ETA metrics are now being produced, which help to reduce vessel idle times. And fundamentally, the improved visibility of all facets of data across an organization can improve the maritime's ability to understand its operations better. So for ports, that can not only minimize the time delays associated with vessels and machinery and assets moving around the ports and moving on to their next terrestrial leg of the journey, it can also help to reduce space. A just-in-time port is not just moving goods through quickly, it's reducing the footprint of that port as well, because there's less space needed for warehousing, less space needed for goods inventory. And that's very important for ports in constrained urban areas. And lastly, we can also marry spatial data of the type that we have shown today with predictive maintenance to more fully understand life cycle management. Predictive maintenance at the moment largely looks at how an asset behaves over its lifespan. But the behavior of that asset and whether it is fundamentally different in different environmental conditions can easily be factored in. Does a vessel operating in the Gulf of Mexico have a fundamentally different lifespan to one operating in the South China Sea? These environmental conditions add important context to predictive maintenance and life cycle management issues, and incorporating those into models through a flexible, holistic data management structure is critical to understanding the context and behaviors more fully. And so at Geospoc, we're here today really to talk to you about these issues. And I hope that we've given you some food for thought, and that when you go away, you think more about the data in your organization and how it moves through your organization. Where are the blockages? Where are the challenges? What do you do with data already? that could be done better? And what do you not do with data because you don't think you're able to, because of siloing, or because you're simply don't communicate that data, those parts of the data that you collect, with other areas of your organization? And at GeoSpot, we're seeking partners within the SSA and the maritime sector at large to support a submission to the Maritime Innovation and Technology Fund administered by the MPA. GeoSpot, we have an innovative database product with a broad use case applicability. However, we understand that often industries are challenged by very specific issues. And we would like to understand those issues further and partner with organizations who have that domain-specific knowledge and use cases and can provide us with access to their data and their current analytics methodologies. So together, we can work on improving those systems, making them future-proof, whatever they may be. So thank you for listening today. If you would like any more information on GeoSpot or on the MPA Mint Fund, please visit those resources. I'll talk to me directly. My email address is on the front page of these slides, which I'll send out afterwards. If there are any questions, please let me know or type them in the chat. Thank you very much for your time.